Okay, so let's dive a little bit deeper into vectors. So in the previous video, we looked at our vectors in the context of them being numeric vectors. However, they don't all have to be numeric vectors. A simple example of a different type of vector could be a character vector. And for handling them, the contents simply need to be enclosed in quotation marks. So let's say, for an example, I want to create a vector that contains students' musical instruments. So what we could do is create an object and call it instruments, and then assign to it a vector using the concatenate function. And let's say we have 5 students. The first student plays clarinet. So in quotations, we could put clarinet, and then we'll put a comma after the quotation. The next instrument, they play saxophone. My third student plays flute. My fourth student plays clarinet. And my fifth student plays oboe. I can run the code. And we notice that a character vector has been created here that contains 5 elements. And the elements are clarinet, saxophone, flute, clarinet, and oboe. So if we come down to the console, I can type instruments just to check the contents of the vector. And it tells me that there are 5 elements: clarinet, saxophone, flute, clarinet, and oboe. And then also I can check the class of the vector. And it's a character vector. Another useful type of vector is a logical vector. So in a logical vector, each element can take on only one of 2 values, either true or false. And the easiest way to generate them is to state claims which are either true or false. So as an example, let's say we want to create a vector that contains permission slip information. We will call the object permission slips, and we will assign to it a vector of my 5 students. Either false, they did not turn in the permission slip, so there's an absence of, or true, they did turn in the permission slip, and there is a presence of. So our first student handed it in. Our second student handed it in. Our third student did not hand it in. Our fourth student handed it in. And our fifth student did not hand it in. I'll run the code. It's assigned to our global environment. I'll come down here just to check. Notice that it's already queued up in our memory, so I can just hit return and it'll catch on to the rest of the vector name. I'll hit return again, and it tells us that there are 5 elements: true, true, false, true, false. I can check the class, and it tells us that it's a character vector. But wait a second, I thought we were creating logical vectors. Well, I made this mistake for a couple reasons. First, it serves us as a reminder that it's always important to go back and check the class of the vector that you're building. You always want to make sure that you're working with the right data type, so that way any future statistical analyses or data analyses that you do are not going to be hindered by a mistake at the data level. And we can also see at the top over here that it did say character vector instead of saying a logical vector. So it's always really important to be checking your work when you write code. Also, I wanted to point out to you that using true and false as logicals, even though they're words, we previously talked about character vectors and putting words within quotations. However, here the computer picks up true and false as a logical and not a word. So what I can do to get back to the previous command, I can hit the up arrow 2 times, and that brings us to where we assign the 5-element logical vector to the object permission slips. And the way we really should have done this was to get rid of the quotation marks, and in capital letters, we can write true, true, false, true, and false. Now, if I hit return, it's going to overwrite permission slips, and then it's going to turn it into a logical vector. We notice you come up here, it says logical vector, true, true, false, true, false. If we now come down and check the class of the permission slips vector, it's now going to tell us that it's a logical. One thing I also wanted to point out is that you're able to change the data type of a vector by using a function. So the way it stands right now is that the data is correct, but just as a teaching moment, I want to highlight this. I'm going to copy it so we can bring it back and check the class once again. and now we have it back as a character vector. What we could do is use the function as.logical. And the argument that we can make inside this function is we can put the name of the vector we want to switch to a logical vector. I'll hit return, and now it comes back as a logical. We could check the class, and it still says character. So what we didn't do, and this is a mistake that beginning students make a lot, is that they forget to assign it to the vector. So what we actually have to do now is take the vector and reassign it as logical. Hit return, and now we notice that it's switched over to logical up here. And then if we check class, it's now a logical. Now, keeping in mind that we made all of those changes in the console, so if you're writing the code and you want to keep reusing this code, even though it's changed in our global environment right now, what we really need to make sure is that the code is correct. So we can come up here, and we should probably change this data to true, true, false, true, true. Now if we run the code, it's going to be assigned as the logical again, and now it's correct in the code. So once again, that demonstrates the difference of working in the console versus working in the script area. So just to reiterate one more time, we can use the asLogical function to change a vector to a logical vector. We can similarly do the same thing. Let's say I wanted to take the permission slips one more time. I can change it to asCharacter, and then permission slips. And then it'll change it to the character vector. So we can use the function asCharacter, asLogical, asInteger, or any of the other data types to coerce a vector to be a certain data type, provided that the elements inside of the vector can be coerced. And we're going to be talking about coercion and specifically the implications for coercion on data in a little bit of a later tutorial.